This story doesn't actually start where you'd think. It starts 10 days before a single person on Earth even knew this thing existed. And by the time this video's over, you're going to understand exactly why two of the most powerful telescopes humanity has ever built, James Webb and the Vera Rubin Observatory, both ended up staring at the exact same object without either one planning to. On July the 1st, 2025, a survey system called ATLAS, that's short for Asteroid Terrestrial Impact Last Alert System, picked up something moving through our solar system, spotted from a facility in Rio Hurtado, Chile. At first, it just got a boring technical label, C2025N1. But within days, astronomers confirmed something wild. This thing wasn't from our solar system at all. It came from interstellar space, and it was only the third confirmed interstellar object in human history. They named it 3I Atlas, and observatories all over the planet immediately locked their attention onto it. Here's where it gets good. A few weeks after the official announcement, scientists working with the brand new Vera C Rubin Observatory in Chile were doing some routine housekeeping, just digging back through old test images from a calibration phase called science validation. And there it was, sitting quietly in the background of images taken on June 21st, 2025. 10 full days before Atlas ever made its announcement, 3I Atlas was already on camera. Nobody at Rubin even knew it. The telescope wasn't hunting for interstellar objects that night. It was just running system checks, pointed at a random patch of sky that happened purely by chance to include exactly where this visitor was passing through. Rubin kept accidentally photographing the object all the way through July 20th, 2025, racking up nearly 100 exposures. Researchers ended up using 49 of those images in a full scientific study. That makes Rubin's images some of the earliest and sharpest pictures of 3I Atlas that exist anywhere, captured completely by accident before most of the world even knew the thing was real. So what did those images actually show? Quite a bit. The data revealed a growing coma. Now that's the cloud of gas and dust around the comet's core, and that cloud expanded by more than 50% during the observation window as the object moved closer to the sun and started heating up. Totally normal comet behavior. But there was one detail that genuinely caught scientists off guard. The dust tail was pointing toward the sun instead of away from it. Normally, a comet's tail points away from the sun because sunlight physically shoves the dust backward. A sunward-facing tail is rare, though it's not unheard of. Researchers have seen something similar on at least one other distant comet. Scientists explain it with something called anisotropic dust emission, meaning the dust wasn't coming off the surface evenly in every direction, which can create weird-looking tails depending on the viewing angle. Strange? Sure, but it's explainable science, not some unsolved mystery. Before we dig into the chemistry, let's talk about the telescope that caught this thing by pure luck. The Vera C Rubin Observatory sits on a mountain called Cerro Pachon in Chile, picked specifically for its dry air and dark skies, ideal for spotting faint objects deep in space. Its main mirror is 8.4 meters wide, roughly the length of a tennis court, and it's paired with the LSST camera, the largest digital camera ever built, 3,200 megapixels in a single shot. When it photographed 3I Atlas, Rubin hadn't even officially started its real mission yet. It was still in a testing phase, basically a dress rehearsal where engineers check every part of the system, optics, camera, software, before the real 10-year survey kicks off. During that phase, the telescope just points at random patches of sky to test image quality and calibration, not to hunt for specific objects. That's exactly why nobody noticed 3I Atlas sitting in those test images for weeks. Researchers only found it after the official discovery, when they went back through the old commissioning data, specifically to check if it might have shown up early by coincidence. It had, hiding in plain sight 10 full days before the rest of the world knew to look. And here's the part that really shows how solid this discovery was. Rubin shoots across 6 different filters covering different colors and wavelengths of light, U, G, R, I, Z, and Y. Scientists measured the object's position across all 6 bands, with a typical precision of about 70 milliarc seconds, an incredibly tiny angle given how far away and how faint the object was. For comparison, Rubin's precision on fixed background stars is even sharper, closer to 3 milliarc seconds, so the slightly wider margin on 3I Atlas just reflects how hard it is to track something actually moving relative to the background sky. That level of detail led a research team led by astronomer Colin Orion Chandler, along with more than 300 collaborating scientists, publish a full paper covering the object's astrometry, precise position tracking, brightness, shape, and activity, all from data nobody meant to capture. Now, let's talk about James Webb, because this is where it all connects. On August 6, 2025, the James Webb Space Telescope pointed its near-infrared spectrograph, NIRSpec, directly at 3I Atlas. This was Webb's first real look at the object, following earlier observations from Hubble and NASA's SPHERIX mission. Webb's job here was totally different from Rubin's. Rubin took pictures, shape, brightness, movement. Webb used spectroscopy to break the comet's light down and figure out its chemical makeup, almost like pulling a fingerprint. And Webb found something unusual almost right away. Inside the coma, scientists detected carbon dioxide, water ice, carbon monoxide, and a smelly compound called carbonyl sulfide. All pretty standard comet ingredients on their own. But the ratio of carbon dioxide to water was the highest ever recorded in any comet, solar system, or interstellar. That ratio matters because it tells astronomers something about the environment the object originally formed in. Different temperatures and sunlight levels leave behind different chemical fingerprints. Then, in December 2025, Webb took another look. After 3I Atlas made its closest pass by the Sun on October 29, 2025, a moment called perihelion, the comet's ancient ice started rapidly turning to gas, making for a brighter, more active coma that was perfect for a closer look. Webb caught this on December 22, 2025, right after the object made its closest approach to Earth on December 19th, a safe 168 million miles out, roughly 270 million kilometers. Zero threat to us at any point. In this second, deeper look, Webb measured something even more revealing. Specific ratios of carbon and deuterium, often called heavy hydrogen, locked in the comet's ice. Those exact ratios don't match anything found in comets that formed inside our own solar system. Working backward from that chemical signature, researchers estimated where and when this object was actually born. And the answer is staggering. Based on Webb's data, scientists calculated that 3I Atlas likely formed somewhere between 10 and 12 billion years ago, in a cold, distant region of the early Milky Way. For comparison, our own solar system, Earth, the Sun, every planet we know, is only about 4.6 billion years old. That means the ice and dust making up this comet were floating through space, frozen and unchanged, for billions of years before our Sun even finished forming. Some researchers have pointed out that this makes 3I Atlas almost as old as the universe itself, which is estimated at roughly 13.8 billion years. This research was formally published in the journal Nature on June 22, 2026, after going through peer review, meaning independent scientists checked the data and conclusions before it was ever allowed to publish. So here's the honest answer to the question everyone online keeps asking. Is this the terrifying alien object some corners of the internet keep insisting it is? No, it's not. And scientists have been crystal clear and consistent about why. First, the object behaves exactly like a comet is supposed to, developing a coma as it approaches the Sun, releasing gas and dust in a pattern that lines up with decades of comet physics from our own solar system. Second, the chemistry Webb detected, carbon dioxide, water ice, carbon monoxide, carbonyl sulfide, is all completely ordinary comet material, the same basic building blocks scientists have cataloged for decades, just in a different ratio, which tells us about temperature and formation conditions, not anything artificial or engineered. Third, its trajectory follows the predictable laws of gravity and orbital mechanics, with no unexplained speed or direction changes that natural outgassing can't account for, the same kind of minor course corrections comets have always shown. It's also worth understanding why this particular chemical signature was so useful for pinning down the object's age. Deuterium, or heavy hydrogen, is a slightly heavier version of a normal hydrogen atom, and the ratio of regular hydrogen to deuterium in ice acts almost like a chemical clock. It changes slowly and predictably based on the temperature and radiation conditions present when the ice first formed. By measuring that ratio with Webb's spectrograph, researchers could work backward and estimate not just how old the ice is, but roughly what kind of environment it originally came from, something scientists call galactic chemical evolution. Our galaxy's chemical makeup has been slowly shifting for billions of years as generations of stars have lived, died, and seeded space with heavier elements. So something formed very early in the galaxy's history carries a slightly different fingerprint than something formed more recently. That's exactly the kind of subtle signal Webb was built to pick up, and exactly why an object like 3I Atlas is such a valuable target. It's basically a frozen time capsule from an era of our galaxy nobody's ever been able to sample directly before. Let's put some real numbers on the table, because the scale of this thing is genuinely impressive on its own. 3I Atlas is only the third interstellar object ever confirmed passing through our solar system, and comparing it to the first two really shows why scientists are so hyped about this one. The first was Oumuamua, discovered in October 2017 by a survey telescope in Hawaii. It was unusual because of its strange elongated shape and a small, unexplained acceleration as it left the solar system, something that briefly fueled a lot of online speculation, though most astronomers concluded it was most likely gas venting off its surface. a natural process that was just hard to directly observe, given how faint and far away the object already was by the time telescopes caught up to it. The second was Borisov, discovered in 2019 by an amateur astronomer in Crimea. Borisov behaved a lot more like a familiar, ordinary comet, complete with a visible tail and coma, which made it easier to study and compare to comets from our own solar system. 3I Atlas is the third, and in some ways the most extreme of the three. Its orbit is far more hyperbolic, more sharply curved and open-ended than either of the other two. Scientists measure orbital shape using a number called eccentricity, where exactly one marks the line between an orbit that eventually loops back and one that never returns. 3I Atlas clocks in at an eccentricity of about 6.14, an extremely high number confirming this object was moving so fast on such a wide open path that it was never gravitationally bound to our sun at any point. It was traveling at roughly 137,000 miles per hour, about 221,000 kilometers per h, as it approached the inner solar system. An almost incomprehensible speed that makes it clear this thing came from somewhere else entirely, passed through briefly, and is leaving again for good on a one-way trip that started somewhere else in the galaxy and will end somewhere else entirely, long after it's left our cosmic neighborhood behind. Based on its speed and trajectory, researchers calculated a kinematic age, roughly how long the object's likely been drifting through interstellar space, landing somewhere between 3 and 11 billion years, a range that lines up closely with the separate chemical age estimate Webb's data produced later. Researchers also noted that statistically, it's extremely unlikely this object has passed anywhere near another star as closely as it just passed our sun, meaning our solar system might be the closest stellar encounter this ancient traveler has had in billions of years of drifting alone through the emptiness of the galaxy. Hubble observations helped scientists estimate the size of the object's solid core, or nucleus, placing it somewhere between about 440 meters and 5.6 kilometers wide. A wide range, because measuring the exact size of a small, distant, actively outgassing object is genuinely tough, even for our best instruments, since the bright coma of gas and dust tends to hide the true edges of the solid nucleus underneath. On top of Hubble, Rubin, and Webb, other missions pitched in too, making this one of the most heavily observed objects in recent astronomy history. NASA's SPHEREX mission picked up infrared light from the coma, detecting dust, water, organic molecules, and carbon dioxide, adding another layer of confirmation using a completely separate instrument and wavelength range. NASA's TESS mission, usually used for hunting exoplanets by watching for tiny dips in starlight, got redirected for a special observation run just to study the comet's activity and rotation. An unusual but valuable use of a telescope that wasn't built for comet science. Even the European spacecraft JUICE, currently on its way to study Jupiter's moons, managed to snap an image of 3I Atlas in November 2025, just because it happened to be in a useful position along its own separate journey. All told, this makes 3I Atlas one of the most thoroughly studied interstellar objects in history. An entire international lineup of telescopes and spacecraft, all pointed at the same tiny, ancient traveler at different points during its brief visit through our neighborhood, each one adding a different piece to the picture. So why does it matter that Rubin and Webb both ended up looking at the exact same object? Because together, they represent two completely different but equally powerful ways of studying the universe. Rubin is built for speed and coverage, constantly scanning huge chunks of the sky, which is exactly why it caught 3I Atlas by accident in the first place, simply by being in the right place, testing its systems at the right time. Webb, on the other hand, is built for depth, extremely precise observation of one target at a time, which is exactly how it managed to pull apart the comet's chemistry down to individual molecules and isotope ratios. One telescope found the object completely by accident. The other figured out what it actually was, where it came from, and roughly how old it is. Neither discovery means nearly as much without the other. Rubin gave scientists the earliest possible timeline and shape data. Webb gave them the deep chemical proof needed to trace this thing's origin back billions of years into our galaxy's history. This story also says something bigger about where astronomy is heading in 2026. The Vera Rubin Observatory officially kicked off its 10-year sky survey on June 30th, 2026, called the Legacy Survey of Space and Time. Its whole purpose is to scan the sky repeatedly, every few nights for an entire decade, catching exactly these kinds of unexpected objects: asteroids, comets, rare interstellar visitors, often before anyone else even knows to look. The fact that Rubin managed to accidentally photograph an interstellar comet before it was even officially discovered, while it was still in testing, months before its real survey even began, is a genuine preview of what this observatory is going to be capable of once it's fully up and running night after night for the next 10 years. Scientists expect more interstellar objects to turn up in the coming years, And when they do, there's a real chance Rubin will be one of the first instruments on Earth to spot them, simply because, unlike almost every telescope before it, it never really stops watching the sky. Meanwhile, James Webb keeps doing exactly what it was built for, taking whatever gets discovered, wherever it comes from, and breaking its light down into detailed chemical evidence that tells us where it was born and how old it is. That's possible because Webb sits far out in space, orbiting roughly 1.5 million kilometers from Earth, away from the heat and light interference of our own planet, letting its infrared instruments pick up incredibly faint signals that would otherwise get completely lost from a telescope on the ground. Together, these two observatories, one constantly scanning wide swaths of sky from a mountaintop in Chile, one capable of incredibly precise, deep analysis from deep space, form a kind of early warning and deep investigation combo for anything unusual passing through our cosmic neighborhood. 3i Atlas just happened to be the first major example of these two systems working together, even though nobody planned it that way. And it almost certainly won't be the last. Right now, 3i's Atlas has already passed its closest point to the Sun and to Earth, and it's heading back out of our solar system for good, quietly and permanently. Scientists kept gathering data as long as the object stayed observable, right up until it got too faint and too far away to track effectively, coordinating observations across ground telescopes, space telescopes, and even a spacecraft on its way to Jupiter, squeezing every last bit of usable data out of this brief one-time visit. What we're left with is a genuinely remarkable scientific record. A comet born 10 to 12 billion years ago, drifting quietly through the galaxy for almost the entire history of the universe, before briefly and completely by chance crossing paths with a handful of human-made telescopes on a small, quiet, blue planet, long enough for us to photograph it, break down its chemistry, and figure out roughly how old it is before it disappears again for good, likely never to be seen by human eyes or instruments again. That's the real story here. Not an alien object, not a terrifying threat. Something arguably way more impressive. Direct physical evidence from a completely different corner of our galaxy, formed before our own solar system even existed, confirmed independently by multiple world-class telescopes working completely independently of each other, and in Rubin's case, working completely by accident, simply because it happened to be pointed the right way on an ordinary test night. It's a genuine reminder that some of the biggest discoveries in science don't come from searching harder. They come from having good enough instruments running often enough that when something rare finally drifts past, you're already there to catch it. Drop a comment and let me know which fact surprised you the most. The accidental discovery 10 days early, the sunward pointing tail, the fact that this object is older than our entire solar system, or the sheer number of telescopes and spacecraft that ended up studying it before it finally left for good.